Hey teenagers, how are you guys doing? Welcome to Geography Now. I am your geography teacher, Miss Shawnette Day. I am super excited about today's topic, so let's get right into it. So today's topic is formation of rocks. Now, not to worry, we're going to go into the types of rocks, how they're actually created, then we're going to go into some more details of each type of rock, some specifics. So stay tuned. All right, so the formation of rocks. Now there are three kinds of rocks. You have the igneous rock, sedimentary rock, and the metamorphic rock. I love metamorphic. I don't know, the word is so complex. So igneous rocks form when molten rock or magma or even lava cools and solidifies. Sedimentary rocks originate when particles settle out of water or air or by precipitation of minerals from water. Now you should remember what precipitation is. If you don't know, come on, write that word down and go and check up. Next, they accumulate in layers. So sedimentary rocks accumulate in layers. Now, metamorphic rocks result when existing rocks are changed by heat, pressure, or reactive fluids such as hot mineral-laden water. So most rocks are made of minerals containing silicon and oxygen, the most abundant element in the Earth's crust. So let's get into igneous rocks. So igneous rocks solidify from molten rock, as mentioned, called magma, okay? Or within the earth, and lava on the surface. So they are identified by mineral content and texture, the size and shape of their mineral grains. Now, texture for the igneous rock is controlled by the rate of cooling. So magma that cools slowly deep in the earth forms rock with large crystals, and lava that cools quickly on the surface forms fine-grained rocks. Let's look at some types of igneous rocks. First, we have the granite pegmatite. Yes, and if you look on screen, you'll see a beautiful image of this type of rock. So this rock formed deep in the crust near to the top of a crystallizing magma chamber. It is composed of the minerals quartz or gray, orthoclase, pink, albite, which is white, and mica, which is like dark and platy. The larger crystals grew more slowly than the smaller crystals. So once again, if you look at that image, you will see a more of a crystal shape, crystal looking, crystal feel, I guess, type of rock. And this rock is called the granite pegmatite. Now let's jump to the diabase. So this rock solidified from a basilistic magma within a few hundred meters of the surface, probably beneath a volcano. It cooled rapidly, giving it a fine-grained, peppery appearance. The black mineral is pyroxene, and the white one is plagioclase. Plagioclase. I know. Let's have a look at this rock on screen. Cool, right? Next, we have diorite. So this rock crystallized in a mountain belt. It contains the minerals plagioclase, which is white, and hornblende, which is black. Once again, let's have a look at this rock, diorite. Now, if you notice, diorite and diabase, they look kind of similar, but one has more of a white texture, as you would see. Now, sedimentary rocks. So what are sedimentary rocks? Sedimentary rocks are layered. Some form when particles of rocks and minerals settle out of water or air. Others form when minerals precipitate directly out of water. So sedimentary rocks are identified by their minerals and textures. So as the sediments pile up, water is driven up by the weight of the overlying pile, and minerals precipitate around the sediment particles, cementing them into the rock. This process is called lithification. Yes? So once again, the process of piling water, overlying minerals, and the involvement of precipitation is called lithification. Let's have a look at some types of sedimentary rocks. The first we have limestone. So limestone is one of the most widespread sedimentary rocks. Many organisms, from corals to microscopic foraminifera, grow shells composed of carbonates. Now, most limestones forms when these organisms die and their carbonate shells accumulate in shallow seas. Imagine how many creatures had to die to form this big rock. Have a look on screen, see the limestone. Next we have shale. So shale is made up of clay and silt. So these particles that are finer than sand. Now clay and silt are deposited in slow moving rivers at the far end of the deltas and in other quiet environments where slowing moving water cannot keep the particles suspended. Let's have a look at shale. Cool, right? Ooh, it looks like Play-Doh. Now let's look at sandstone. So sandstone is made up of sand which accumulates in rivers and along ocean shores where water moves fast enough to remove the finer particles. Sandstones can also be deposited by winds to form sand dunes. Let's have a look at what sandstone looks like. I wonder what the durability would be like as well. That looks so cool as well. Lastly, as I said, my favorite rock, I don't know, because of the name, metamorphic rocks. Reminds me of Power Rangers, I don't know why. So metamorphic rocks, from when sedimentary, igneous, or pre-existing metamorphic rocks are changed by heat, pressure, and chemically reactive waters. These rocks were identified by the minerals and textures. So during metamorphism, new minerals grow with different sizes, shapes, and orientations than those of the original minerals. The chemical composition of the original rock may also change as some elements are carried away and others are added by the fluids flowing. So let's look at some types of metamorphic rocks. We first have the Manhattan schist. Cool, right? Originally a shale, this schist now consists of dark, biotite-rich layers and finer grained, light-colored layers made of gray quartz and white orthoclase. The distinct layering developed perpendicular to the direction of compression. This schist underlies most of Manhattan. And here, let's have an image. Look at what the Manhattan schist looks like. Next we have the slate. So this slate was also once called a shale. Because the shale was metamorphosed only slightly, its textures changed a little. This sample, okay, is from a Greenville slate widely used for roofing. Boom, there it is. Look at that, such a beauty. The next we have Genesis. This rock was once a granite, as it was deformed by heat and pressure. The original even-grained rock developed dark layers, primarily biotite, and light layers, mostly gray quartz, pink orthoclase, and black horn blende. Alright, so there was an image of the Genesis. Now this brings us to the end of our lesson on the formation of rocks. I trust that you were paying keen attention and you have taken in and you've absorbed all this information. If not, don't forget you have your geography textbooks and you also have access to the internet. Please study, makes you, I don't know, I guess smarter. It does make you smarter. Be good, be safe. This was Geography Now with Miss Shana Day. Bye.